if we have 3/4 times 2/5 times 10/7 times 1/3. You want to multiply these fractions. And many students like to multiply all the numerators, multiply all the denominators, and then reduce. But that is not the most efficient strategy. Rather, we're going to go ahead and factor and cancel. We make one big fraction bar. 3 cannot be factored. 3 is 3, but 4 is 2 times 2. 2 is 2. 5 is 5. 10 is 2 times 5. 7 is 7. 1 is 1. 3 is 3. So looking at this, we can rewrite it as 3 times 2 times 2 times 5 times 1 over 2 times 2 times 5 times 7 times 3. These are essentially prime factors, and I'm going to divide out the things that are the same. So you'll notice I have 3 upstairs, 3 downstairs. 3 divided by 3 is the same as 1 divided by 1. Hence I rewrite 3 over 3 as 1 over 1. 2 divided by 2 is the same as 1 over 1. 2 divided by 2 is the same as 1 over 1. 5 divided by 5 is the same as 1 over 1. And my result upstairs, 1 times 1 times 1 times 1 times 1 is 1. Downstairs, 1, 1, 1, 7, 1. Downstairs is 1/7. So the result of that question is going to indeed be 1/7. We can also take a look at a situation with mixed numbers. If I have 2 2/3 times 1 1/4, the strategy is the same. So 2 2/3, so it's supposed to be 2 plus 2/3 times 1 1/4. 2 2/3 times 1 1/4. We'll rewrite those as top-heavy fractions. 3 times 2 is 6. 6 plus 2 is 8. 8 over 3 times 4 times 1 is 4, plus 1 is 5. Times 5 over 4. So if we're going to go ahead and do this, we're going to factor everything. 8, 4 times 2, or even better, 2 times 2 times 2. Prime factors of 8. 3 is 3. 5 is 5. 4 is 2 times 2. So writing this as a single fraction, we get 2 times 2 times 2 times 5 over 3 times 2 times 2. So the things that are the same on the top and the bottom we can divide out. 2 divided by 2 is the same as 1 divided by 1. 2 divided by 2 is the same as 1 divided by 1. Leaving me with upstairs 1 times 1 times 2 times 5, 10. Downstairs 3 times 1 times 1, 3. But in this class we prefer to have mixed numbers, so we're going to rewrite 10/3 as 3 into 10. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. Remainder is 1, and the result is 3 1/3. Now with respect to division, division just requires us to take the reciprocal of the second fraction and multiply. So let's take a look at another mixed number sort of question. If I have 3 1/2 divided by 2 3/4, the strategy is going to go ahead and convert each one of these things into a top-heavy fraction or an improper fraction. 2 times 3 is 6 and 1 is 7. 7/2 divided by 4 times 2 is 8 and 3 is 11. Divided by 11/4. And this then requires us to rewrite that as 7/2 times 4/11, which we're going to go ahead and factor everything. 7 over 2. 4 is 2 times 2, and 11 is just 11. The only thing that cancels here is a 2 over 2. 2 over 2 cancels. 7 times 1 times 2. 14 over 11. Then we take 11 into 14. 11 into 14 one time. 1 times 11 is 11. 14 minus 11 is 3. So 1 and 3/11 is our answer to that question. Now we can extend this idea into the domain of healthcare by taking a look at a couple word problems. So for example, if the question is as follows: you give a patient four tablets from a bottle labeled 2/3 grain each. How much medication has the patient received? So you can see this is a standard health-based question. Well, we know we have 4 tablets. Times 2/3 of a grain per tablet. We're going to use our technique of fraction multiplication to make sense of this. Now looking at the number parts, we have 4 over 1. Remember, 4 is a whole number. To make whole numbers into fractions, you divide by 1 times 2/3. But then we have tablets times grains per tablets. And the thing is nice that we handle the units the same way we do the multiplication of fractions. So tablets divides tablets, leaving just grains as a solution. But let's also work with the numbers. So 4 is 2 times 2 over 1 times 2 over 3, and we see our result here is grains. 2, 4, 8, 8/3 grain. And let's rewrite 8/3 using mixed numbers. So 3 and 8, how many times? 2. 2 times 3 is 6. 8 minus 6 is 2. Remainder is 2. 2 and 2/3. 2 and 2/3 grain. And let's take a look at one more question. To give 375 milligrams of ascorbic acid from 250 milligram tablets. How many tablets would you use? And the way I like to do this is I want to convert from milligrams to tablets. So we have here is we have 375 milligrams over 1. We want to convert that to tablets. So I need the milligrams to cancel. So I'm going to need milligrams on the bottom to cancel milligrams. I'm going to need tablets on top. Now, 1 tablet is how many milligrams? 1 tablet is 250 milligrams. So you'll notice milligrams goes away, tablets is left, so we get 375 over 250 tablets, which is 1 1/2